Hey, welcome back. In this lecture, we are going to explore about different data of a program. Data will come with different variations or different types. Here in this diagram, you are seeing such variations of a data. First of all, a data can be a global data. Let's start from here, global data. And that global data can be either initialized or uninitialized. Global data is nothing but your global variable of a project. If that global variable, if it is not initialized, that means that data is not carrying any important information. If it is not carrying any important information, then would you store that in data section? No, you need not to store that in data section. Why? Because if you do that, then it would unnecessarily consume the flash space or ROM space. Because remember that data section you are going to store in the ROM, and the C startup has to relocate that to RAM. If a global variable which is uninitialized, and since it is not carrying any valuable information, then it doesn't make any sense to store that in data section. That's the reason why compiler says that the global uninitialized data doesn't belong to data section. It belongs to slightly different section, which is called as BSS. And I'm going to explain BSS later. Let's go further. How about global initialized data? Global initialized data, yes, it carries some important information. It's initialized. That's the reason why it should be stored in the data section. It should be stored permanently in the ROM because that's the important data. After that, how about global uninitialized static data? Global uninitialized static data is a private data. It's a global private data to a source file where it is defined. Again, it is not carrying any valuable information, then that's the reason it is not stored in the data section. It will be moved to the BSS section. How about global initialized static data? Global initialized static data is stored in .data section. How about local uninitialized data? This is a local variable of a function. This is created in stack. It doesn't have any section because it's a transient data which is created and destroyed dynamically when the program control enters that function. That's why these data will get created in the stack, and when the control goes out of scope of a function, these data will be destroyed. Same thing applies to local initialized data as well. And now next, how about local uninitialized static data? A local static data is a kind of global data, but it is private to a function. That's the reason it is treated as a global variable. But since it is uninitialized, it would occupy the BSS section. How about local initialized static data? Again, as I said, it would be treated as a global data, but private to a function. And since it is initialized, it would consume the data section. In summary, global initialized data, whenever you see initialized, global, and static, when you see these three words together, you can say that those variables will consume data section. If you take global initialized, it has two addresses: a load time address, that is when you load the executable into the microcontroller flash memory, it has to go and sit in the flash. That's why it has two addresses. One is called as load address or load time address, that we call as LMA, load memory address. Load memory address is in flash, and this is called VMA. And the startup code relocates that section to RAM. The address at which it is relocated is called as virtual memory address. There is nothing virtual actually. This word has been taken from the ELF standard. Basically, in the case of microcontroller, everything is physical. There is nothing virtual here. That's why the dot data section has two addresses, LMA and VMA. This we'll be using while writing the linker script. How about global uninitialized? It is BSS section, and it doesn't have any load address because it is not stored in flash. Only a space is reserved in RAM. Startup code reserves space for this data in RAM and initializes to 0. So your startup code has to do that. After that, global static initialized, again it has a load address and virtual memory address, that is runtime address. Like that. Local initialized, it goes into stack. It is consumed at runtime actually. It doesn't have any load time or runtime. It doesn't have any section dedicated to that. After that, how about constant data? All global const will go to flash. Since they are constant, they are not writable, isn't it? They are only readable. That's why there is no runtime memory consumed by the const variables or const data. And the section dedicated is this one, .ro data. And all local const, that is constant data which is local to a function, those are just treated as a stack data. They don't have any section dedicated to that. That's about different types of data you find in a program. And let me know if you have any questions. I'll see you in the next lecture.